this formula sheet. It has sine law there, but I find it just as is. It's not quite as robust as I would like it to be. So I would like you to have an example how to do inverse, right? Like have an example on your study sheet. Cosine law is also represented. So worst case scenario, you can always come back to this. But I would still say, so I'm going to give you my version of these formulas. Okay. Did you get the joke here? Why couldn't trigonometry get a loan? Because nobody would cosine. I don't know if you're familiar with the word cosigner. Somebody, if you can't afford, if you don't have good credit, somebody has to sign for you, like on behalf of you. So that's, yeah, there we go. Yeah. Anyways, so far, we were able to solve any oblique triangles using sine law, but what if you're given a triangle without a pair? This is what everything hinges on. This is how you will know, oh, it's cosine law, right? If you're given the following scenarios, we need to use the cosine law. So it's the first one is this one. You have what we call an SAS. Focus on the letters here. The angle is sandwiched between the two sides. That is the key here. So in a sense, I draw my triangles like this. And if you wanted to focus in on this angle here, you would know the angle and you would know the side lengths of both sides. Page 15. So SAS is the first one. You will have to use cosine law. And then the other one is SSS. Obviously, what does that tell you? Side, side, side. So I know I'm making the triangles all look the same. Don't think that that's going to be the case. But these are the giveaways. But what do you notice in both cases? Is there a way to get a pair out of this scenario right here? No. Right? Is there a way to get a pair here? No, there's not even an angle, right? You can't even get a pair. So again, as I said, if there's no pair, then you have to go cosine law. Right? The thing is, technically there's only one formula, but I will give you two versions because it's much easier to work with the two version as opposed to with just the one. Okay. So let's go with the formulas right here. So I'll go SAS first. So I'll tell you this. This is where I use my different color. Okay. So if you have this triangle right here, and you have side angle side, make sure you follow here. Side angle side. So that would mean, for example, let's say you would know this side, and the angle in between. This is side angle side. The only thing you could do at this point is to solve for that side that's across the angle that you have. And this is how you would write it. This is how you would start your formula if you wanted to solve for A. Got it? You would go A squared, that's where I use the different color, is equal to, at first this looks like Pythagorean theorem. It's going to be equal to the other two sides squared, and add it. Okay? And here's where it changes. Minus 2 times B times C. What's the pattern here? If I want the one side, I need to take the other two sides, square them, and add them. Then I'm going to have to go minus 2 times, so the 2 is always there, B, that's the first side I had here, C, right? So these two numbers will appear again here, but they're not squared, times cosine of angle A. Do you see that pattern? The red, like if I want side A, then I need the angle across from it. That's the only way this thing works. Okay, so I'll say these are the other two sides. Okay? And then this is the angle across side A. Okay, so I'm just going to tell you something here. All of the numbers, all of these letters on the right side of the equal sign, you will know them all. Every single one will be replaced by a number. Okay? What do you do if you have a squared? What did you do in with Pythagorean theorem to just get a square root? Okay, so basically, I will tell you that you're going to do a bunch of work, and then at the end, to get a, you will take the square root of a number, and then you have a. I'm just going to leave it like that. Obviously, this can be much more compressed in your work. Okay, you're finding a side length here. Okay, guys, finding side length. You're not solving for an angle here. You're solving for the side length. So that's when you have an SAS scenario. I just want to make sure you understand that it could have been that the SAS happened on this corner, right, where the angle is here and you have the two sides there. It could have happened up here where you have these two sides and the angle sandwiched in between. So it would change based on the scenario. I just gave you one version of it. Now let's look at side, side, side. You know all three sides. Okay? The beauty is the only thing left to solve in this triangle is what? Angles, right? The sides are already all taken care of. Got it? So you get to pick which angle you want to solve for. So you have to be very careful. Which one do you want to solve for? I'm going to purposely not go with A today. I'm going to say let's try to solve for angle B, because otherwise you're always going to think it's A, right? If we wanted to solve for that one, watch what we do. It has some similarities to this side, but you start like this. Cosine of angle B is equal to, watch this, this is the pattern on this side. You're going to have to add two numbers and subtract a third one. And that's where I use my different color. This one is going to be the most important to put down. If you want to solve for angle B, guess which side you're going to have to subtract here. It's always opposites, right? So this will be B squared like this. So this side is across that angle. And you're left with sides A and C, correct? So that's what you go and fill in here. A squared plus B squared minus, sorry. You know what I mean, right? Sorry, I backfired. Right, it's A and C, but B is across here, okay? Down here, it's going to be this part right here, the 2 times. 2 times A times C. But B should not show up anywhere else anymore. You only subtract it once here because it's the angle you're trying to find. Okay? And you're going to do a bunch of work. Guess what's going to happen in order for you to find angle B? What's going to be on this side? Earlier it was sine inverse. Now it's going to be cos inverse of some sort of number, which we're going to get when we crunch all of this. Right? We're going to figure out what that is, so that's going to be there. So you find an angle. So when it's SSS, the only choice you have is to solve for an angle. If you have SAS, your only option is to solve for a side length. You're with me? You can do this. I'm making a big deal out of this, but it's really not that bad. By the way, if you solve for side A, Do you have a pair now? You could switch over to sine law. All right. But at the beginning, at the very beginning, you only have one choice. It's either sine law or cosine law. You cannot, there's no such thing as I can maybe use this one or that one in this course, okay? So let's go and put this to the test. 16. I'm going to start with SAS. And then I'll let you practice right away so you don't fall asleep on me. Is there a pair? No. So it's cosine law, right? And more specifically, side angle side. By the way, this is not showing your work. This is just kind of us getting ready for the work. Some students think, hey, SAS, we're done, right? No, it's not. So what's the only side I can solve for here? In this scenario, that side tells me that I have to solve for side A, right? That's all I have. That's my only option. So I'm going to write out the formula first. A squared is equal to, in this case, it's ABC again. So it'd be B squared plus C squared minus 2 times B times C times cosine of angle A. I almost wish I would have changed the letters because, yeah, I don't want you to fixate on ABC so much. I want you to fixate on the pattern. A squared, B is what? B is 7.9. Here's where you have to have a good calculator. It's going to make your life so much easier. C is 5.2 minus 2 times 7.9 times 5.2 times cosine of the only angle that shows up. You can't get this one wrong. The angle, you just cannot get that one wrong. It's the only angle that you will ever have if you're in this scenario. Mind you, later on, if you solve more, there will be more options, of course, right? So now this is what I do. Watch this. I go A is equal to, don't forget about the square root, because that's about the most common error I can think of. And my calculator is right here. So maybe just look up. You can type this in one shot and get it right every time. I would actually recommend you do that if your calculator allows you to do that. 7.9. I have an X2 button. I don't know about you. If you have that one, that's great. That squares it automatically. So I go squared plus 5.2 X2, that squares it, minus 2 times 7.9 times 5.2 times cosine of 43. I typed it all in one shot. If you have brackets and you prefer to use brackets, that's perfect. I hit equals, and that is what I put in here. Do not round. Right? Just leave it like that. Would that even make sense as your answer right now? It's a little bit on the, right? Like 5.2, 7.9, all of a sudden you have a 29, and it's a relatively small angle. So yeah, don't forget to root it. So I'm going to go press the square root button, hit equals, and it does that for me. It does everything for me. So that's 5.42 centimeters. It's a bit more realistic, right, this answer? So I'll leave it at that for now. I'm not going to do the part that says solve a triangle using sine law. We're just going to stay right here. Okay, before I move on, I need you to practice at least one. Okay, so let's go to 17 and practice your skills. Okay, can I just ask you, because there is a chance that you might get into problems with this one if your calculator is not the way mine works. So let's agree to do B first. We'll do B first, and then when you're done that, you go to A. Just in case there's a hiccup there. I'll give you the answer. If you don't want to know, then don't look up. Okay, try it. This is basically checking your calculator right now. Do you know how to operate it? Okay, 17 to 19. if you still have your calculator out, if not, just look up here. 91 is an obtuse angle. Do we know what an obtuse angle is? Bigger than 90. 90.01 is already obtuse. So if you go cosine, watch this, cosine of 91, what do you notice is different? There's a negative. You see that one right there? So you have to be careful with that one. Unless you're typing everything in one shot, you will never have to worry about it. Which I think, from what I'm seeing, all of you are all right. So I will talk about it briefly tomorrow, and then we'll do the side, and then we'll start mixing it up, where you have to decide, is it sine law or is it cosine law?